Hello, everyone. How are we all doing? I don't know whether to say on this afternoon or on this evening, but hello. Just doing a little mic check to make sure you can hear me. Awesome. I saw Tiana put her hand up. There's some thumbs up coming. Amazing. Okay, I'm just going to wait 2 more minutes for others to join before we get started. I'm also just looking at which campus everyone comes from. And it's looking like mainly my online students, which is very exciting. Ah, actually, I'm going through. Is there anyone that's in the session that is not an online student? Anyone in the session not online? So far, I don't see anyone that I think is not from online. Nope. Okay, amazing. Okay, so we'll start at like 2, 3 minutes past. We'll just see if any others join. I'm quite excited if it is just us online peeps. That's actually really nice. So I won't be too disappointed if other people don't join and it's just us this evening. So to my online students, how are you guys doing? How are you getting on with things? Have you found is it the third week already of semester? I can't believe it. How's it going so far? Let me know in the chat while we wait for a moment. Okay, so let's have a look. We've got so far everything's good, all good. It's going good, thanks. That's good news. I'm glad to see everything is good. That's amazing. Good, wonderful. Okay. Sure, I've just had some very warm coffee and now I'm starting to sweat. Don't know if that happens to anyone else, but I'm feeling the heat. Okay, well, I think we can get started. I'm looking through all of the students. I'm so sorry I don't know my own students yet. I promise I will get to know you guys after a couple more lessons, but it does look like everyone here is from online, which means you guys are in my IQTT class, which I absolutely love because that just means we're giving some extra special attention to our online students, and you guys deserve it. Okay. Um, all right, let's get started. So, guys, the point of this session, essentially why these sessions were set up, is primarily for late reg students. So students who have registered after semester started and maybe are feeling a little bit behind. So, the session is intended for both online and contact students. As we know, with contact, they have a lot of classes in a week. Online, it is more self-paced. You only see me once every 2 weeks. Um, so, for you guys, hopefully you would have been working in your own time, but still, we don't go through things in like a lecture kind of format when we do meet. So it is quite nice that we have this session where it really is just dedicated to covering a lot of the important concepts that make up Learning Unit 1, and just getting you up to speed of where you kind of should be in your third week of this module. So that's what we're going to look at today. And then in my online class that I have next week with you guys, we will look at our worksheet as we had planned to do. So today will be more of a lecture session. We will record it so that we can share it with other students. And then from next week, we'll continue with what we had planned for our session. Okay. All right. Seeing as we are all online, I apologize that I have to go over this introductory bit one more time, just for the sake of the recording, but we won't spend too long on it, and then we can jump in and actually get into some content. Okay. Please feel free at any point to just unmute, to pop in the chats. You're soon going to learn with me that it is very much a two-way thing, these online sessions that we have. So very seldom do I just talk to you. Sometimes I do love to talk a little bit too much, I know. Um, but I very much rely on you guys to help me when it comes to coming up with the answers, giving problems a try. Even if you're not sure of what the answer is, it is so valuable for you to just give it a go because very often someone else will have the similar thinking to you. Maybe they're too shy to say it. And by you actually offering up your potential solution, you might be helping them to see, even if it's not correct, to see the error in their thinking. So it really is a safe space for us all to participate. Okay. All right. So I'm going to start recording. Oh, it has already. Okay, awesome. Okay, so let us get started with just an overview of the module. So obviously IQTT stands for Introduction to Quantitative Thinking and Techniques. It is a course that runs along a variety of different qualifications. So IQTT, it is in our High Certificate in Web and App Development in the School of IT. It is in Human Resource Management. It is in Business Practices and Principles. So a variety of different modules have IQTT in it. And the reason being is whether you are going into business, whether you're going into IT, having a fundamental understanding of maths is paramount. It's important in your day-to-day life, but it's also important if you're going to further your studies. So for instance, I studied economics, and economics is pretty much all math. So, you might think, oh, maybe economics has some graphs or, something like that. Well, actually, it is 90% maths. So there's a lot of different subjects that actually require maths knowledge. Um, Now, I also know that a lot of you will come into this with quite a bit of anxiety around maths, either because you've had really bad experiences in the past, maybe you had a terrible maths teacher that you just didn't understand, or perhaps you just thought, I can't do maths. Well, I'm here to tell you that everybody can do maths. Yes, it is more challenging for some of us. When I was a matric, when I was studying for my exams, I used to literally have notebooks and notebooks of practice questions because that was the only way that I could get it right. So even if it might seem like for some of us, oh, you guys you've got it easy, it's not easy for anybody, but you can manage. Okay, so I just want to give you that reassurance before we start. Okay, so very quickly, what do you need for this module? So you need to get the module outline as you do for all of your modules. This is a document that highlights what makes up the module in terms of the learning unit. So what exactly is it going to cover? And it also includes things like assessment information, prescribed readings, all of that sort of thing. Then for this module, there is no textbook, which I love because it means you guys don't have to spend a fortune on buying another textbook. So this module comes with the module manual, and if you haven't downloaded it yet, you can get it off the student intranet under student material. What I did with my module manual, it has been very well used, as you can see. I just printed mine out and I had it bound. And I've used this for 4 years. That's how long. I've actually been teaching this module for 5 years now. So it didn't cost me that much to do this. And it's really nice, particularly if you like me and you like something hard copy to be able to scribble on. So that's the module manual. It might look like it's got quite a lot of pages, but a lot of it is activities. So don't be daunted thinking, oh my goodness, this is so much content. A lot of it is just practice activities with their solutions, which is really nice. Okay, and then you're going to need a scientific calculator. People often ask me what type of calculator is best. I have no idea. I have always just used my good old Casio calculator. As you can see, it's been with me for many years because it has a Hello Kitty sticker on the back. So whatever calculator, scientific calculator you have, I'm sure will be sufficient. Don't go thinking you need to buy some special fancy type of scientific calculator. And then the last thing is access to Excel. Now, what's quite nice is that through the IIE, you do have access to all of the Microsoft applications in your browser, and you can access them via the student internet by clicking on the little waffle menu in the top left corner that opens up all your applications. And there you can access Excel if you don't have it on your computer. Reason you need access to Excel is because our assignment has got Excel in it. We've got one assignment that is pretty much primarily just Excel. So that assignment's quite cool because it takes everything that you've been doing manually up until now, so using your calculator, doing manual calculations, and it looks at how can we use Excel to do these calculations for us in a way that's very quick and efficient. So it's actually a really lovely assignment because it's quite practical. Okay, then in terms of the learning units, there are 7 learning units that make up this module, starting with Introduction to Numeracy, which is what we're going to start looking at tonight. So Introduction to Numeracy is such a diverse learning unit. It covers things like basic calculations. When I say basic calculations, I'm talking addition, subtraction, multiplication, division. Then it goes on to things like fractions, BODMAS, things like averages, finding a missing value, exponents, so your laws of exponents, which is vital for algebra. So that's very important. It looks at percentage calculations and also some stuff on ratios and proportions. So introduction to numeracy really is quite a broad introduction, but it really does form the fundamentals for the learning units to come. So for example, if you are not strong in learning unit 1 when it comes to exponents, you're going to struggle when we get to algebra because algebra builds on the rules of exponents. So it's very important that you spend a bit of time on learning unit 1 to make sure that your foundations are so strong. Another example, for instance, is percentage work. So percentages comes up in learning unit 7 again. Now, if you have mastered percentages in learning unit 1, you have to learn nothing new for learning unit 7. You just need to learn how to apply your existing knowledge to a financial mathematics scenario. So I'm really trying to emphasize learning unit 1 is important. Okay, then we've got algebra. That I know does scare people, but don't worry, don't let it scare you. It starts off quite simplistic, and it just has 1 or 2 more complicated things where we look at things like linear equations and simultaneous equations. But otherwise, it's not too bad. Then we've got tables and graphs, Excel, statistical measures, which is looking at things like mean, median, mode, standard deviation, variance, and that kind of thing. Then geometry. Geometry to me is the most random of learning units, but at least you'll know how much paint you'll need if you ever want to paint your house one day. So it's handy nonetheless. And then financial maths. So financial maths is a great one because it's very applicable to our daily lives. It's looking at things like tax, things like adding a markup, a markdown if you are a business owner. Um, so very much, I would say, practical kind of content in the financial maths section. Now, I'm not sure if we've got any contact students that have now joined us. Are there any contact students in the session? Are we all still distance? All still distanced? Okay, we are. I love it, guys. I'm feeling the support tonight. That's great. Okay, so contact versus distance, we do have different assessments. So for distance students who are in the session with me right now, you guys have 2 assignments. Your first assignment is based on learning units 1 and learning units 2. Your second assignment is learning units 1 to 4. You then have a written on campus exam, which covers all learning units. I should add here, it covers all learning units except Excel. So Excel would be quite hard to test in an exam situation because obviously you don't have access to Excel. So it is all learning units except learning unit 4. And then you have to complete 4 of the 6 ICE tasks. So that is the assessment structure for distance. If you're a contact student, you do a written on-campus test, you do an assignment, the exam, and 4 ICE tasks. So the big difference between contact and distance is contact you have a test, whereas in distance you have 2 assignments instead of a test and an assignment, which I think is quite nice. All right. So before we jump into the content of the module, I just want to get a sense from you guys. How much time have you been able to spend looking at Learning Unit 1? Was there anything in Learning Unit 1 that stood out as a little bit tricky? I just want to gauge from you guys where you are at currently with the module. So you can unmute, you can pop a message in the chat. Okay, perfect. Nazia, I hope, guys, I just have to warn you ahead of time. I know I've said this to my class. My pronunciation of names is horrendous. I tell everyone I've inherited from my dad. I can't help it. I was born like this. But I do try my best. So please don't be offended if at any stage I mispronounce your name. I will get it right. Okay. So one person's responded. Everyone else? You can be very honest with me. I was also a student once, so I completely understand if you haven't even opened your book yet. Maybe you are someone who really has just registered, last week, for instance. It's just to help me know exactly where to start with you guys this evening. Okay, while you are busy doing that and letting me know in the chat, I'm going to upload my slides for this evening. All right, we've got Kieran who says not very far, done a bit and completed ICE task 1, but struggling a bit to fit work and studies as well, but making a plan. Yeah, flip guys, I know that that's so difficult to try and manage both work and studies. I don't know how people get it right. I take my hat off to you. It really is tough. I mean, I was a full-time student and I found that difficult. So I can't even imagine having a job and trying to juggle studying. That really is very understandable. Okay, I'm waiting for Sarah's comments before I get started. Okay, Tiana says on our WhatsApp group, someone was asking how thorough should the explanation be for the answers in activity 1.1.1. Okay, I think that question is going to be answered quite nicely as we start to work through practice questions tonight, because you'll get a good idea of the kinds of workings that I show. One thing I can tell you is I've had a few students in the past who have wanted to write me explanations, as in text explanations of what they've done in a calculation. I don't need that. Your lecturer doesn't need that. What we need to see is just your workings, your full workings. I always say, pretend that I'm not your lecturer, pretend that I don't know, like that it's not obvious to me, and show every single step that you take to get to your answer. You would always rather show more workings than not show any workings and then lose those marks. Okay. All right, I'm just putting myself on do not disturb here because I can see. All right. Getting messages on the side. Okay, so someone got their hand up. Sarah, hello.
Hi, ma'am.
Hi.
Hello. I just wanted to ask if there was a WhatsApp group for this module because I see someone's commenting about it, but I wasn't in the last online collab because I had something on. But I don't know if there was a WhatsApp group that was made or not.
Okay, yeah. So just in case any contact students have joined since I last went and checked, um, in the distance space, we do have a WhatsApp group. So if you are a distance student, there is a WhatsApp group for IQTT. Sarah, I have shared the link to join the group in announcements on ARC. So if you, I think it's our latest announcement. I've put the link that you can just click on to join um, our WhatsApp group.
Okay, I'll look. Thank you so much.
It's a pleasure. Alrighty. So let us begin then. We are going to jump into the content. Okay, so Learning Unit 1, let's take a quick look. I know I did mention some of the topics that are going to be covered in this learning unit. Starts off with the basic calculations, looks a little bit at number lines and inequalities. So inequalities are important to understand. When I talk about inequalities, I'm talking about things like bigger than, less than, greater than or equal to, less than or equal to. So I'm talking about those signs that indicate which side of an equation is larger or smaller. And that might seem very simple in this learning unit, but it's important you understand those inequalities because in algebra, we will look at how to rearrange and solve inequalities. Okay, then we look at the number line and negative numbers, fractions, some stuff on BODMAS, the commutative, associative, and distributive laws, averages, finding missing values, and then, so I would say from averages to the end, these are really important areas to focus on. So I'm actually just going to mark them. Um, Obviously, all content is important to cover, but I would say averages, finding missing values, exponents, approximation, which is rounding off, percentages and ratios and proportions. Those are your most important sections from Learning Unit 1. So I really want to encourage you to take more time in practicing the questions in your module manual relating to these sections because they do come up in the longer questions of your assessments. So, for instance, there's always an averages question. There's always a finding the missing value question. Exponents, you will definitely be tested on that. Rounding off, you will 100% get rounding off questions in your assessments. Same with percentages and ratios as well. There's a standard ratio question that tends to always repeat itself. So it's really important that you are prepared for that. So just take note of those important areas that I'm highlighting. Okay, are we good to get started? I am going to ask if you have a calculator that you go fetch it quick. So I'm going to give you 2 minutes to quickly go fetch a calculator and then we'll start. Okay, quick 2 minutes. Can others see my screen? Can you just indicate in the chats? You can't. It seems like all of the people that have joined as external users can't see the screen, but those that are logged in to their BC Connect accounts, I think will be able to. Can others give me a thumbs up or I'll quickly see if there's a setting that I can change to allow everybody to see. I didn't set up the meeting, so I don't have the setting options. Hmm. Okay, can others indicate if they can or can't see the screen so that I can see if it's an external user issue? Okay, that does seem that that's what the issue is. Okay, So I can see that those that have not logged into their account. So in other words, you haven't accessed this while being logged in to your Varsity College account. You are not seeing the screen because it is recognizing you as an external person that's not part of our organization. So what I would do to rectify that is if you just go into your browser and you open up your email, or you go from Arc, but you must be logged into your account in your browser. So you logged into your email, you logged into Arc, then click on the link to join this session, and it should take you into Teams logged in as yourself, so that when you join, it doesn't show you as an external person anymore. Does that make sense? Sorry about that, guys. I see there is just one or two of you that are external. Okay, we're going to continue though. All right, guys. So what I'm going to look at tonight is I'm going to focus on some of the things that I know students generally struggle with. We will look at those things and areas that I feel are very important because they're going to prepare you for your assessments and for later learning units to come. So what I'm going to do is I'm going to start today with averages. Um, I'm going to start today with averages and we're going to see how much we can cover after averages. All right. Are you guys happy with that? Okay, good. Good, good. Perfect. All right, great. Okay, so who wants to tell me what an average is? Or give me an example of an average. So when I say to you, I want to calculate the average student mark for my class, what do I mean when I say that? Anyone want to unmute? You can type in the chat. There'll be lots of awkward silences if I don't have some people helping me tonight. Vera, yes.
I don't know how to explain it, but I know you usually just add all the outcomes together and then just divide by the amount in total.
Perfect. That is a great explanation. I love it because you've actually just given the method. Absolutely. So if I want to work out the average, for instance, of all of the IQTT students, assignment one marks, just like Sarah said, I would go and add all of those marks together and divide by the number of students, and that's going to give me the average grade. So it's essentially taking them, summing them, dividing by how many students, and that will give you the average. So most average questions are pretty straightforward. It gets a little bit more tricky where you start to look at the finding missing values, but let's start with a simple averages question. All right, so here's a good example of averages. We've got here a student scored the following marks for 5 tests during the semester. The test scores carry an equal weight. So we've got the 5 test scores. Then it's asked, what is this student's average mark? So who wants to tell me how we would calculate this? Lot of silence. I'm hoping that people are typing because they're going to help me find the answer. That's fine, Sarah, no problem. Okay, so I'm going to assist you. So before we get going, yes, there's someone with their hand up.
Hi,
Miss
ma'am. I don't know if you can
Lani.
hear me.
I
Hi, ma'am. Can you
can.
hear me?
I can.
Okay. So what I would do is I would add up the five scores up together, and then I'll divide them by 5 and get the average like that.
Absolutely, that is 100% correct. So,
Mm, okay,
thank you so much for that. So
no
that's
problem.
absolutely the correct method. Now I'm going to show you how to make sure you answer it in such a way that you get full marks. So in maths, we have a formula that represents how to find the average, and another word for the average is the mean. So when we get to statistical measures, we will look at the mean. And it's very important that you know this mathematical formula because it's always worth 1 mark. And I'm going to write it down. It is going to look like Greek because it is Greek. So these are actually Greek letters, but it's important that you learn this when it comes to averages. So let's choose a nice color pen. All right. So this formula that I'm writing on screen now, that is the mathematical formula for averages. Okay. So it looks a little bit intimidating. The first thing we've got here is x with a bar above it. Now, the mathematicians decided to give it such a creative name, they called it x bar. Very creative, right? So x bar, this sign right here, an x with a bar above it, that means average or it means the mean. This little signal, or this little sign that looks like a E, that is called sigma. So sigma means sum. So when we say sigma x, each one of these values here are different x values. So this we could call x1, this we could call x2, x3, x4, and x5. So what this is saying to us is that we need to sum all of our x values. Okay? And then below that we have an n. Now n means the number of values. Okay, so we've got x bar, this here is the average. We've got sigma, this means the sum. And we've got n, which means the total. So how many values in total we have. Okay, so it's important that you always write this formula up front, and that's important for both questions on averages and questions on the mean. Okay. All right, so once we've done that, we can then go and insert our information into the formula. So we can say the average score for this student is equal to 100 plus 80 plus 60 plus 51 plus 79. Now, you might want to go and do that on your calculator and just put in that total, but you will lose a mark. You actually have to show that you are adding all of those values together, and then we can divide by n, which is 5. Okay, I don't know who has their calculator on them. I'm not sure if anyone does, so I will use mine, but hopefully someone does grab one at some stage because it's also nice to have someone check me. So let's see, does anyone have their Oh, Nazia, absolutely. Thank you for confirming it is 74. So our final answer is 74%. All right. So what you also could have done, so this here is perfectly sufficient in terms of your workings, but what you might like to also include just for your own sake is you can add up the 100, the 80, the 60, the 51, the 79, put the total over 5, and then give your final answer. That's up to you, but what I've written on screen is sufficient for full marks for this question. Something just to note, and that is the units of measurement. So whenever we give an answer, we indicate the units of measurement. So that could be, let's say we're taking our ruler and we're measuring how long a small piece of paper is, for instance. Okay, that would be in centimeters or meters. So when you give your final answer, you need to indicate what it is telling us. Like, is it 74%? Is it 74 rand? Is it 74 meters? And you need to think about that whenever you're answering a question. What should my answer be telling me? And have I included the necessary information for my lecturer to read it and know what my answer is telling me? Okay. All right, I can see there is a few questions in the chats. Mm, okay, so those relate to ice stars. I'm going to answer those separately. Okay. All right, so that's quite an easy question, right? Can I get some thumbs up, thumbs down? Chilled question? Okay, good. I'm glad. I'm glad. I'm glad. All right. Now I'm just going to look for another nice question for us. Okay, here we go. This is a good one. So let's have a look at question 2 here. Easy peasy. I know it is easy peasy. Okay, so let's have a look at question number 2 here. So it says, what is the average of 4 hours 15 minutes, 5 hours 42 minutes, and 11 hours 57 minutes? So now we're dealing with a question where we've got two different units of measurement. We've got both hours and we've got minutes. How are we going to calculate the average for this question? Anyone want to assist me? Convert each of them to minutes. Absolutely. All right, so how do we convert 4 hours to minutes? Follow the same formula, exactly. So what do we have to do to 4 hours to convert it to minutes? Multiply by 60? Absolutely. So let's do that. Thank you very much. So that's exactly what we have to do. So if would go 4 times 60. And then what about this 15 minutes? What do we do with that to make sure we incorporate it? Add it. Lovely. So you want to do the 4 times 60 first, and then you want to add the 15. Perfect. Thank you, guys. And we'll do the same here. So we'll say 5 times 60 plus 42. And then with the last one, the same thing. So we'll go 11 times 60 plus 57. Okay, so let's do our little formula. X bar, we know, is equal to sigma, which is the sum of all our values over n. Now let's enter our values in. Okay, can someone help me with what is 4 times 60 plus 15? 4 times 60 plus 15. Oh, perfect. You're so on it. I want to try to pronounce your name. Is it Mithlali? Is that right? Am I completely off? I like to be able to say someone's name, especially when they get something right. Oh, yay. Okay, good, good. All right, thank you so much. So we've got 255. And then what about 5 times 60 plus 42? 342. Nazia, Tiana, thank you so much. So plus 342, wonderful. And our very last one, 11 times 60 plus 57. 717. Okay. Lovely. Thank you. And I love how a lot of you are doing this. So I'm getting confirmation and I don't need to go and check on my calculator. So thank you. And then what are we dividing it by here? What is our n value in this case? 3. Thank you, guys. Nazia, Tiana, thank you so much. It is 3. And now we can go ahead and do this on our calculator. Remember, you can do it more step by step. So if you want to first add 255, 342, and 717, you can. Can anyone tell me what we get if we did add those 3 together? Lovely. 438. And we're dividing by 3. Thanks, guys. So what is our final answer going to be? Oh, is that the final answer? Oh, you guys, I should have recognized that. How do I find the eraser here? Okay, I'm quickly going to add up the values just to show the in-between step. 255 plus 342 plus 717. And we've got 1314. And you're absolutely right. If we divide that by 3, we get, oh, we get 438. Now tell me it's 438 what? Is this minutes? Is this hours? Okay, it is minutes. Aha. Mithlali, I want you to tell me how you got 7 hours and 18 minutes. What did you do to get that?
So I divided 438 by 60, and then I got
Lovely.
7, and then I got 0.3 as my remainder, so I timed that by 60.
Wonderful. So often people get stuck with that. So they will go, and I apologize for running out of space here. So we'll continue this over here. So we know that it's 438 minutes. So you're absolutely right. We're going to take the 438 and we're going to divide it by 60. Now we always want to try and give our final answer in the same way it is presented in the question. So the question presents it as hours and minutes. So when we give our final answer, we want to try and do the same thing. So we went 438 divided by 60, which gives 7.3. Now this doesn't mean 7.3 as in 3 minutes. Oh, guys, what's happening to my slides? Is someone else changing them or is that me? So what this indicates then is it is 7 hours and it's 0.3 of another hour. Okay, so it's not 0.3 minutes, it is 0.3 of an hour. So this here would give us 7 hours. And to work out what that 0.3 is, we would take 0.3 and we would times it by 60, and that's going to give us 18. So we know it's 7 hours and 18 minutes as our final answer. Thank you so much. You guys are on it. I'm feeling like this stuff is so easy peasy for you. Averages chilled. Okay. All right, good. Okay, so now I want to show you a slightly different question. And I'm going to actually get a worksheet that I've created. And let's take a look at the worksheet. So now this question takes us our averages and it spices it up a little. So let me just get it open. I'm going to have to share a different screen. Okay, here we go. Now, let's share the screen. Alrighty. Are you guys able to see my Microsoft Word screen? You got me? Wonderful. Okay. So let's have a look at my question 4 that I have here on averages. Now, these are slightly different average questions, and these are the kind of questions you're going to get in your assessment. So they won't be the straightforward kind of average questions that we've looked at, but those are important to be able to understand this. So let's have a look at the first question. It says 5 students write an exam. The average score obtained on the exam by the group of students is 68%. If the first student obtained 66%, while the next 3 students each obtained a mark of 62%, what was the mark obtained by the 5th student? So what are we thinking here? So it's telling us we've got 5 students writing an exam, and it's giving us the average score. So it's telling us that the average score is 68%. But what's missing is the 5th student's mark. How do we go about finding that? Now, it's helpful if you remember the method to calculate average. Anyone got any ideas? Yes, we had a hand up. Sarah?
Ma'am, I already did this question, but like, can I say how I did it?
Yes, of course. Oh, yay, I'm glad you did it. Perfect. Please tell me.
I said 68, and then I times it by 5 because there's 5 students. And then I got
Lovely.
the answer, which is 340. And then I took away the, like, so the one was obviously 3 of them all the same. So it comes up to like 186. And then also took away the 66 from the one student, which is the answer. I hope.
Perfect. Let's take a look. That looks very good. Okay, so remember what we normally do when we get an average is we've added all of the student marks together, we've divided by 5 the total students, and it gives us our average. So we need to work backwards now. So if we divided by 5 to get the average of 68, we now need to multiply the average by 5 to give us the total sum if we added all 5 students' marks together. So we're going backwards. So we're going to say, all right, we've got 68%. Okay, we can leave off the percent. So 68 times 5. And that gives us, I know, Sarah, you did tell me some figures, but gives us 340. So that means that the total scores, if we added all 5 together, would give us 340. Now, if we minus from 340 everything that we know, so for instance, we know the first student obtained 66%, we know that the next 3 obtained 62%. So if we subtract those from the total of 340, what we're left with is the final student's mark. So what we would do next is we would take the 340 and we're going to subtract from that 66 for our first student. We were then told the next 3 got 62. So we're going to minus 62 3 times. And what we are left with is our missing value. So let's do that. We've got 340, we're going to minus 66, minus 62, minus 62, minus 62. Anyone got an answer, Sarah? What did you come out with at the end? You're going to be brave.
88.
What was that?
88.
88 is absolutely correct. Well done. Okay, so 88%. And Miss Lali also got it right. Amazing. Nashia, thank you guys. So does that make sense? So it's essentially working backwards. It's like, okay, we've been given the average, we know the total, multiply that average by the total, subtract the values we do know, and we're left with the value we don't know. Okay. All right. So sorry for my distant students because now I'm jumping ahead to this worksheet, but I just thought it is important that we don't just look at the simple average questions. We look at the ones that are a little bit more challenging. All right. Now question 2 here is even builds a little bit further on that. So question 2 says the average height of 12 seedlings is 6 centimeters. Okay, so once again, we can see that we've been given the average. We know that the average is 6. And we also know that we have got 12 seedlings in total. Then it tells us the total height of 10 of the seedlings is 60 centimeters. Of the 2 remaining seedlings, the first is double the height of the second. Give the individual heights of these 2 seedlings. Okay, so let's just go back and see what this is asking us. So there are 12 seedlings. Their average height is 6 centimeters. We know 10 of the 12, all of their heights added together gives us 60. But we're missing 2. And what they've told us is that the first seedling is double the height of the second. So we need to find 2 missing values. How are we going to do that? Does anyone want to give that a try? Okay, silence. I completely get it. It is a little bit of an intimidating one. So how I like to answer this is I know that algebra is only learning unit 2, but algebra for me is a really helpful way of writing it out, seeing it clearly, and then solving for the things we don't know. So what I would do in this situation is I would say let x equal the height of the second seedling. So we know we're missing 2 seedlings, right? So I would say let x equal the height of the second seedling. If x is the height of the second seedling, how much taller is the first seedling? Like what would we need to do to x to get the height of the first seedling if it's double the height of the second?
Wouldn't it just be 2x?
Correct. That's exactly it. So let 2x equal the height of the first seedling. Okay. So do you see how we have used the letter X to represent the height of both seedlings? And the fact that we know the relationship between the two, sorry about the, don't know if you guys can hear the thunder outside, but it's loud. So we've let X represent one of the heights, then we've used the relationship between the two to be able to actually come up with something to represent both of the heights that we don't know. Okay. So what I would do next then is I would set up my little equation. So I would say, I want to say x bar. Oh, I don't need to actually. So our average is 6, right? Average height is 6. So 6 is equal to, we're going to do a little fraction. My screen is freezing. I feel like I'm getting a not responding message here. Come on. Oh no, guys. Let's try again. Completely frozen. Okay, I'm going to stop sharing and try share again. The stock is completely frozen. Okay, what I'll do is I'm going to share the whiteboard instead, and I'll just rewrite the question for us. Okie dokie. So let us move all of this over and get a new whiteboard. All right, perfect. brand new blank slate. Okay, so let me just remind us of the question very quickly. So we've got the average height of 12 seedlings is 6 centimeters. Oh, you know what I could probably do here? I could just take a screenshot of the question and paste it. Let's see if that works. Ha! Look at that. Don't we love technology when it works and doesn't freeze? All right, so there's our question. So what we had said was to let x equal the height of the second seedling. I'll make it bigger for you now. Let 2x equal the height of the first seedling. All right, let's make this bigger. All right, cool. Now I'm going to use our little equation. So let us, there's too many options here. Like I just need a pen. All right. So we know our average is 6. So we've got 6 is equal to, and then we have been told that the combined heights of 10 of the seedlings is 60 centimeters. So what we're going to do is we're going to take the 60, but we know that to get the total height of all 12, we need to account for these two little missing seedlings. So we're going to add them. We're going to say plus the height of the second and plus the height of the first. And then we are dividing by 12. So do you see here how I'm doing exactly what we did when calculating the average, except now we know the average. What we don't know is actually sitting up at the top of this fraction here. Making sense so far? Got some thumbs up? Okay, good, good, I'm glad. All right, so now what we can do is we can simplify this a bit. And can anyone remember how do we add x plus 2x? So we've got x, yes, Sarah?
Are you asking how you add x plus 2x?
Yeah.
It's 3x.
It is 3x. So perfect. So when we are adding like terms, so x's are both like terms, when we're adding like terms, we would simply add the numbers in front of the variable. So in this case, we've got a 2, and in front of the x is a little imaginary 1. We don't write it, but it is implied. So Sarah, you're absolutely right. So we've got 6 is equal to 60 plus 3x over 12. Now we can rearrange this to make 3x the subject of the formula. Can anyone remember how to rearrange to get x as the subject? Yes, Sarah, go for it.
So you want to take, I would take the 12 to the other side, and because it's dividing on the right hand side, I would times it by the 6. That's the first step.
Lovely.
I don't know if you want to do the whole thing.
I'm going to. Perfect. So 6 times 12 would give us 72.
So then what's left? 60 plus 3x. So then I'll take over the 60 and I'll minus it from whatever's on the left.
Amazing. So 72 minus 60 will give us 12.
And then you're going to take your 3 over to the other side and divide it because it's timesing by the x on the right.
Amazing. Thank you, Sarah. I can see you are going to fly when it comes to algebra. I just can see it. All right. So Sarah's absolutely right. To get the x by itself, we just need to get rid of that 3. Because it's 3 times x, to move it across, we need to divide by 3. And 12 divided by 3 will give us 4. So now tell me, what have I worked out here? I've got x is equal to 4. But what have I actually calculated? Because remember, we're missing 2 values. So what have I calculated here? Or Sarah, what has Sarah calculated here? The first seedling, exactly, because we said X, well, it's actually the second seedling, but you're on the right track there. So we said let X be the height of the second seedling because that's the smaller one. So we know that our second seedling, the height is equal to 4 centimeters. Now, what about the height of our first seedling? How do we know what that is? So if we said that the first seedling is double the height of the second, eight, love it. So we simply need to go 2 times x, so that's 2 times 4, which gives us 8 centimeters. And that is the height of our first seedling. Okay. Are there any questions around that, guys? No problem, Tiana. Thank you so much for joining. That's wonderful. Good luck. Okay, any questions around this section? It's fine to say if you lost at any point. We all good? Yes? Okay. I've got one thumbs up. All right. There's another one. Thank you. Thank you. Perfect. So guys, what we're going to, yes, Matwa, Monelwa, you want to ask a question?
Yes, please, ma'am. Can you hear me?
I can.
Okay. If you can just go back quickly there by 72 is equals to 60 plus 3x.
Yes.
If you can just repeat that step again for me, please, ma'am.
Of course I can.
Okay, thank you.
No problem. So what we did here is we're trying to isolate obviously the x3. We're trying to get that to be by itself. Okay, so we want to isolate the 3x. Now, the first thing we want to do is get rid of this 12. Now, at the moment, it's 60 plus 3x divided by 12. So in order to move the 12 across, we have to do the opposite operation. So if it's divided by 12, we need to multiply both sides by 12. So that's why we did 6 times 12, which gives us 72. That then moves the 12 across. And that's why we then dropped the fraction and it became 72 is equal to 60 plus 3x. Does that make sense? I hope so. Yes, wonderful. Okay, so folks, we are now going to move on to exponents, but I wanted to know, we've just passed our first hour. Would you like to have a short 5-minute comfort break before we move on to exponents? Completely up to you. Post in the chat if you would like that, or if you would prefer we just carry on. We'll let this be a little bit of a democracy here. Chat, folks, little break or carry on? I take that as you want to carry on? Yes? Everyone's silent. You don't mind to continue. Okay, perfect. Everyone else okay? All right, well, your silence says it all, so we will continue. All right, so let us then move on. I see 2 people are typing. Okay, I'll give you a moment because I'm very aware that this could be quite long. We can continue. Perfect. Sarah, you've got your hands up.
This doesn't have anything to do with the topic, but I just wanted to ask. So I don't know if I missed an announcement, but is this collab, is it going to be the same thing that is, you're shaking your head, is it not the same?
You mean the same thing as what we're going to be doing next week?
Yeah.
No, different.
So both are important.
Both are important. So in
Okay.
this, I'm spending more time explaining the concepts. In our session that we do together next week, we're going to look at exam and test and assignment questions that relate to this learning unit.
Okay. Okay, thank you.
Okay, cool. All right, let's continue then. So as I mentioned, I am focusing on the areas that I sort of think are quite important. We've had a look at averages. I think you guys have got that down. Now let us move on to exponents. So exponents are actually quite easy to work with once you understand the rules. So we're going to just take a moment to look at the rules and some very simple examples. So these examples we'll build upon, and if you are one of my distance students, we'll do some more challenging examples together. But this is just to help you get the fundamentals right. So there are 7 or 8 rules to exponents. I think it's 7, if I'm not mistaken. Um, Let me just check. I feel like I should know that. 8. 8 rules. Okay. So we're going to familiarize ourselves with those 8 rules now, and then we'll do some application. Okay. So rule number 1 says, when you multiply 2 variables with the same base, you can add the exponents. Oh my goodness, when you read that. So let's just break it down. Um, when I'm talking about variables, what do we mean by variable? Can anybody tell me? What would we mean by a variable? Yes, Sarah. Absolutely. So the variables are the letters, and while they're called variables, it's because they are placeholders for a number. So when you see an X, a Y, a Z, they are essentially placeholders that could take a variety of different values. And that's why we call them variables, because they could vary in the values that they take. So variables that have the same base in this case, when we talk about base, so if we are looking at something like x to the power of m, so that m is the exponent and the x part is the base of the exponent. So think about it as the letter that sits at the bottom and the exponent sits on top. It is the base. Okay. So 2 variables with the same base basically means 2 of the same letters. So if we have all x, all y, all z, we can then add our exponents together. So let's look at these really basic examples here, just to make sure that we understand these rules. So the first one we've got is x squared times x to the power of 4. How would we simplify that applying this rule? I see we've got some typing. Sarah's got her hand up. Sarah? Oh, you broke up there?
Sorry, I said that you just have to add the exponents because 4,
Ex
so it's
ex
x to the power of 6.
Absolutely, you're so right. And Nashia has the same answer. So it would be x 2 plus 4, which is equal to x to the power of 6. Now, something very important to mention, sorry, this 4 looks very wacky, is when you are doing these, and they won't be as simple as this because it'll be a few rules built into one question. So it might be 3 or 4 rules that you will apply in one question. But it's very important that you show me that you understand the rule by showing that addition. So if you just gave the answer x to the power of 6, you're going to get 1 mark. You'll get a second mark for actually showing me that you're adding the exponents. So it's a really important step. Okay, the next one here says simplify x to the power of 4 times x cubed. How would we simplify that? Okay, Nashia said it would stay the same. Sarah, do you agree?
Multiply x and then add the exponents. So x, y, power 7.
Okay, so that is something bases are different. That is exactly why we can't add them. So a lot of people make this mistake. It's a very common one. So yes, the bases are different. We have an x to the power of 4, we've got a y to the power of 3. Because those are different bases, we can't add them. So that means we actually can't simplify here. So our answer will stay as x to the power of 4 and y to the power of 3. Okay. All right, so that's rule number 1. If we have the same bases multiplied together, we can add the exponents. Let's have a look at the second rule. So rule number 2 says, when you have an exponent expression that is raised to a power, you can multiply the exponent and the power. Okay, once again, that sentence sounds so confusing, and it really isn't. So this here would be an exponent expression, x to the power of m. Now that whole thing is all to the power of n. Okay, so there's essentially an exponent on an exponent. Now in this case, what we can do is multiply the two exponents together in order to simplify. So this would be x to the power of m times n. Okay, so let's have a look. Let's do this first one. So this here we would have x, and what's going to happen above the x? Anybody? Thank you, Sarah. I'm very grateful for you this evening.
It's 2 times 4. So it's
2 times 4? Exactly. Thank you so much. 2 times 4, which gives us x to the power of 8. Lovely. Okay, so these right now, it's probably you're probably thinking, oh, this is nice and simple. But it is so important that we refresh your knowledge of these skills. So even if you're thinking, oh, this looks really easy, it's still good just to refresh your mind, okay? So stay with us. Okay, now here we haven't got a variable. We've got 2 squared all to the power of 3. So same thing applies. And how would we simplify? Someone else want to give it a try? Okay. Lesme says 2 to the power of 3 times 2. Exactly. Perfect. So it's 2 to the power of 2 times 3. And that gives us 2 to the power of 6. And does anyone know what 2 to the power of 6 is? 64, lovely. So in this case, we actually come out with a lovely answer that has no variables in it. Nashia, thank you so much for those workings. Those are spot on. Lovely. Okay, so rule 2, done. So we've looked so far at if we are multiplying two expressions with the same base, that we can add the exponents. We've then looked at how if we have an exponent expression that's to a power, we can multiply that exponent and that power together to simplify. Let's take a look at the third rule. Okay, so the third rule says if you have a product inside brackets and a power outside of the brackets, then the power goes on each element inside. Okay, so let's start by where it says a product inside brackets. What does that mean? Anyone tell me what that means? Yes, Sarah.
Yeah.
We've got you.
Can you just repeat the question because I don't know. Did you
Oh,
say I mean for the product or
what does the product mean?
is it like the result when you multiply two things together?
Yes, Absolutely. You mentioned exactly what I wanted you to, which was the multiplication. So product means that whatever's in our brackets is being multiplied together. And this is really important. And I tell you why, because this rule does not apply if there's addition or subtraction in that bracket. So let's go over the rule and then I'll show you cases where it doesn't apply. And this is really important because I see this mistake made often with students. So it says, if you have a product inside brackets and a power outside the brackets, then the power goes on each element inside. So in other words, that little power can be distributed onto the y and onto the x. So it becomes y to the power of n and x to the power of n. So let us do this one over here. Does anyone want to give this one a try? So we've got x times y squared all to the power of 3. How would we simplify that? Now this incorporates two rules. It incorporates this rule now and rule number 2. Okay, we've got Nashira typing away there. I have a feeling she's going to give us some full workings. Or I'm not sure. I'm so sorry. Okay, we got lots of typing. Nashia, you're also more than welcome to unmute. Okay, let's see what you've written here. So we've got x to the power of 3, y to the power of 2 times 3. Amazing. Absolutely. So we mustn't forget now, we're going to be applying that 3 to each of the variables in the brackets. So the x is just to the power of 1, so that's fine. It becomes x to the power of 3. But with our y, because we already have y squared, we need to use rule 2 and multiply the 2 by the 3. This will then give us x to the power of 3 and y to the power of 6. Lovely. Okay, let's do this next one. So the next one here I will do for us. And we obviously have to apply the 2. So we're going to have x3 times 2 and y4 times 2. And that gives us x to the power of 6 and y to the power of 8. Okay, now let me show you which circumstances this would not work in. And this is really important to remember. So if you have something like this, y plus x to the power of n, okay, you cannot distribute that n in if there is a plus sign. It will not work. So if you tell me that this is equal to y to the power of n plus x to the power of n, that is wrong, okay? Same as if we had y minus x to the power of n, that cannot be simplified in the same way. So you'll see now, this only applies in the case where we have the product and where we have division. So where we have multiplication or division, then this rule applies. If in the bracket there is any addition or subtraction, this rule no longer applies. So that's a really important thing to remember. Okay, are we good to move on to the next one? We'll take a break at 1:30. Okay, let's move on to the next one. All right. Okay, so here it is the same rule. So it's still rule number 3. But now we've got division. So I'd said to you that this will work if we have multiplication or division. So here we've got division. So if we look here, we've got x divided by y squared, if we look at our example 1. So if the same rule applies, what are we going to get if we simplify x over y to the power of 2? And if you want to type in the chat, you can always indicate the line that separates the numerator and the denominator with a slash. Okay, got Nashira typing. Okay, and we've got x to the power of 2 over y to the power of 2. Exactly, it's the exact same rule. So we're taking that 2, we're applying it to the x, we're also applying it down to the y, so it becomes x squared over y squared. Now, with the next example, once again, here we're using rule 2 and rule 3 because we already have exponents. So we have an exponent expression to a power. So we mustn't forget in that case, we multiply the exponents and the power. So we'll have x 3 times 2 over y 4 times 2, which will give us x to the power of 6 over y to the power of 8. Okay. How are we feeling about these exponent rules? Not too bad, I hope. Good. I can see some little clapping hands. That's great. Thumbs up. Amazing. Okay, we're nearly at the end of exponent rules. I know that this beginning stuff can be a bit boring, so thank you just for staying and persevering with it. Promise it will get more interesting. All right, let's jump on then and have a look at the next rule. So rule number 4 is a really easy one, and it's just one you need to remember, is that anything to the power of 0 is equal to 1. Okay, so if you have 20 billion to the power of 0, it's still 1. That is just the rule. Okay, and I've seen this question actually come up quite a few times in assessments where they give you like I don't know, 7,000 to the power of 0, and they want you to simplify it. So it's just to remember it's 1. If you ever forget and you're like, I forgot this rule, does it equal 0? Does it equal 1? Just put in any value on your calculator. So I'm putting in 6. So I'm going 6 to the power of, here we go, 6 to the power of 0. And what do I get on my calculator? I get 0. I get 1, not 0. So you can always double check on your calculator. You can take any value and you can, I'm going to put in 1,000 to the power of 0 and I get 1. So you can always test it on your calculator. Take any number, put it to the power of 0 and you'll see you always get 1. Okay, the next one, is that 1 to any power equals 1. So if you think about it, 1 times 1 is 1. 1 times 1 times 1 is 1. 1 times 1 times 1 times 1 times 1 times 1 times 1 is 1. So no matter what power it is, 1 to any power is always going to be 1. And once again, you can test it on your calculator. So if you can't remember this, put in 1 to the power of 10 and see what you get. You'll notice you get 1. Okay. All right, so this here, rule number 6, I've never actually seen tested, and it's unfortunately come up a little bit strangely in my slides. But rule number 6 says that a power can also be a fraction. So did you know? So we could have x to the power of a half. That is a completely valid exponent. So you could have something like where you have x to the power of a half all to the power of 2. And in that case, you will go x a half times 2. Okay, now an alternative way of writing a exponent that is a fraction is to write it as a root. So if I have x to the power of a half, that can also be written as the square root of x. If I have x to the power of a third, that can also be written as the cube root of x. So it's just an alternative way of writing it. I've never seen this come up in assessments, but I just want you to know that these two are equivalent. So when you have a variable that has a fraction as its exponent, it is equivalent to taking the root of the exponent. Okay, but I've never really seen that used, although I have seen cases where you've had to apply rules, like in this case, where an exponent might be, say, a half, and then you might have to multiply that by a power. But I've never seen you have to use this before, but it's just good to know. Okay, rule number 7 is an important one. Okay, so when we are dealing with algebra, what we tend to want is always to have positive exponents. So in your final answer, you should try never to have a negative exponent. And the way you can achieve that is by turning your exponent expression into a fraction. So this is called the reciprocal. So let me show you some examples. Let's say we have got x to the power of negative 2. Let's say that's our final answer. You don't want to present your final answer with a negative exponent. You'll lose a mark. So if you want to give your final answer with all positive exponents, you will present the reciprocal, which is 1 over x squared. It's the same if we had x to the power of negative 100. You could present it with a positive exponent by turning it into a fraction and giving us the reciprocal. So it's important to know that an expression with a negative power can also be written as a fraction with a positive power. Okay, now I'm going to open up to you and say, do you have any questions on this? Sarah?
I just want to ask, so when you put this, for this rule 6, a power can be a fraction, when you put the
Yes.
x to a square root, if they put it like that, like let's say in a test or whatever, whenever, if that's like difficult to work out, because let's say it says the square root of x, the power of something, then can you put it in the other format, like x to the power of a half,
Yes.
instead,
Yes.
work it out?
Yes. Yes.
Okay. Thank
Yes.
you.
Absolutely. Absolutely. You've got it.
Okay.
Perfect. Okay, I see Kieran is typing, so I'll just give a moment. I was busy writing. Can you explain rule 7, please? Of course. No problem. So I was saying that in maths, when it comes to exponents, we never want our final answer to have a negative exponent. Now, these two, when I look here at this fraction and this x with the negative exponent, these are called reciprocals of one another. In other words, they mean the same thing. Okay, they're just different ways of presenting them. So if you come out ever with a final answer with a negative exponent, you need to present the reciprocal of that to give us a positive exponent, and that would be turning it into a fraction. So if we just rub this out and we'll give some more examples. So let's say we have, I'll give like quite a good practical one here. Let's just choose a different color pen. So let's say we've got x, y, and we've got y. Actually, let's do a better example. I'm going to give you a really nice practical application of this. So let's say we've got x to the power of negative 2, and we've got y to the power of 1, and all of that is to the power of 4. Okay? To simplify that, we know that we have to take that 4 and apply it to the x and to the y. So it would be x negative 2 times 4 times y to the power of 4. Now, if I simplify this, I get x to the power of negative 8 times y to the power of 4. Now, we never want to have that negative exponent in our final answer. So to turn it into a positive, I'm going to present the reciprocal. So the y to the power of positive 4 is going to stay at the top of the fraction, and the x to the power of the negative 8 is going to go to the bottom of the fraction, but now the exponent becomes a positive. So do you see how by turning it into a fraction, I am able to then have all of my exponents as positive in my final answer? Got it. Which one? So y is to the power of 1, but remember, any variable that doesn't have an exponent on it is to the power of 1. And we just don't write it. So I could write a 1 there, but look, 1 times 4 is just going to give me 4. So if I did 4 times 1, that's just going to give me 4. So I just leave the 1 off because I know 1 times anything. Like 1 times 4, just give me 4. 1 times 100 would just give me 100. So we don't always write the 1. Okay, perfect. Guys, we've got one more rule, then we'll take a break. Okay, this is an important one. This comes up quite a lot. So when dividing two like terms, so once again, variables that are the same letter, we can subtract the exponents. So here we've got x to the power of m over x to the power of n. And we can simplify that by simply subtracting, oh goodness, the m and the n. So let's look at a practical example. So we might have x to the power of 5 over x to the power of 2. That can be simplified by going x 5 minus 2, which is equal to x to the power of 3. Let's look at a slightly more complicated one that maybe has two variables. So we could have x to the power of 4, y to the power of 2 over x to the power of 3 and y. How would I simplify this one? Does anyone want to give this a go? So it's exactly the same as what I've done above. Yes, Nashira, please answer. I'd love to hear your voice.
Okay, so you'd say x to the power of 4 minus x to the power of 3, so that would be x4 minus 3.
Lovely.
And then y to the power, is that z?
No, it's
Or
a 2.
Sorry.
No, that's
Sorry.
my handwriting.
And then minus 1.
Minus 1. Lovely. So you see there, the y at the bottom doesn't have a 1, but it's implied. Okay, it's implied. So that's lovely. So it's no longer a fraction anymore. So now we've got x to the power of 2 and y to the power of 1, which we can leave off, but it's fine if you write it. Okay. Thank you so much for answering that. That's awesome. Okay, guys, any questions on the rules of exponents? Remember, they are really important, so it is essential that if you have got questions, you take this opportunity now to ask. All right. Yes, is that a question?
And then I'd like to ask, how is the answer x to the power of 2 if it is 4 minus 3?
Oh, that's a very good point. It should be 1. Thank you for picking that up. That's just a very tired brain on my part. And this is why I need you guys to just check up on me. Thank you. That's why I always say, especially to my online students, please bring your calculator because by the time we have our sessions at night, I feel like we always need a second pair of eyes on the final answer. So thank you. Okay, so actually they're both to the power of 1, so we could leave the 1 off. Okay, guys, let's take a 7-minute break. We'll come back at 18:40 and we will look at some percentage work. I know it is a long evening session. Totally understand if you have to go. This will be recorded, but it would be really amazing if some of you did stick around. So we'll take just a 7-minute break and at 18:40 we will come back to continue. Are you guys okay with that? Amazing. Okay, I'll see you, Nana. I'm going to just quickly put the whiteboard on. Oh, actually, I can just put a message here. to say we will continue shortly. Okay, I'll see you guys then. All righty, are we all starting to return? I'm so glad to see that none of you have left. I'm very impressed by everybody's dedication to the session because I know it's quite long. Okay. All right, are we back? Can I get some reactions from you so I know you're here? Yay! Thank you. Okay, so we're going to continue now with some percentage work. And this percentage work is once again the fundamentals of percentages. What is really great though about mastering it here at the stage of learning unit 1 is that it's going to set you up for learning unit 7. And what you're going to see, especially when I teach learning unit 7, I literally just link it back to learning unit 1. I'm like, guys, this is nothing new. It's what you've been doing since the start of semester, and you are absolutely sorted. So what I've included here is the way the module manual explains things, okay? Which very often can sound quite confusing. And it's more helpful if you look at an example to understand what they're talking about. So there's a few things we're going to calculate when it comes to percentages, and the first is the percentage rate. So these percentage calculations, I think you'll be very familiar with because you would have done them. For instance, you get your mark on a test, you want to work out what is that as a percentage, you would automatically do a little calculation. So some of these will be familiar. So calculating the percentage rate, it says to express x as a percent of y, you take x divided by y and times by 100. Okay, we'll see how that's applicable now. And then calculating the percentage amount. So to compute x percent of y, you take x divided by 100 times by y. Okay, that doesn't mean much when I read it like that, I know. So let's go and look at how we would apply that. Okay, so calculating the percentage rate, let's look at the first question. Calculate 27 as a percentage of 41. So let's say you got 27 out of 41 on a test. How would you convert that to a percentage? And just so you know, when we talk about percentage rate, a percentage is a rate. It's a rate of change. And so when we're talking about calculating the percentage rate, ultimately we want to come out with some kind of percentage value at the end. So how would we do this? How would we calculate 27 as a percent of 41? This one is actually it's an easy one. So give it a go, be brave. Yes, Sarah.
It would say 27 over 41 and then times 100.
Exactly. So 27 over 41 times by 100. Thank you for the workings in the chat. Tasme, you're amazing. And 27, is that? So let's have a look. 27 divided by 41 times 100, and we get 65.86. I think you can double check me there. You'll also notice that I've rounded off, and that's really important. So that's actually, this is a great time to talk about rounding off. So no, that's okay. There's me. That's absolutely perfect. I can see you wrote 21 instead of 27. That's absolutely perfect. So by default, you should always round off to 2 decimal places. So it's important to remember with your rounding off. So if we ask to round off to 2 decimal places, let's say your answer is 65.853, like it is in this case. Because we've got a 3 after the 5, it means we're rounding down, so it stays as 85. If we had 65.857, because that 7 is greater than 5, we would be rounding up. Okay, so important always to round your answers off to 2 decimal places. Okay, so in other words, what we've calculated here is that 27 is 65.85% of 41. Okay, so we're going to make that a percentage. All right, let's look at the next one. What is 104 as a percentage of 371? Another easy one for us. Because it's getting late in the evening and we need to give our brain a rest. Anybody? Yes, Sarah.
Matt, is it just asking for like the same thing, the percent?
Yep.
So 104 is 371 times 100.
Perfect. Great. And let's see what that gives us. So we've got 104 divided by 371 times 100, and we come out with 28.03%. 28.03. Okay, so I think those are quite straightforward. That's calculations that you would have been doing. Thank you for confirming the correct answer. So yeah, hopefully that's very familiar to you. And now let's have a look at calculating the percentage amount. So in this case, we're saying we want to know what X percent of an amount is. Now, what I want to just ask you guys is, do we remember BODMAS? Like going back to school days when we were talking about our orders of operation. Okay, I'm glad to see a thumbs up. So BODMAS essentially tells us what we need to do first. And does anybody know what the O stands for? What does the O stand for in BODMAS? Sarah?
I've seen two different ways because some people say of and like if it is of something and a number, but some people say it's other, like for exponents or square roots and stuff like that.
Interesting. Interesting. Yeah, absolutely. So in this context, I want you to think of, and wherever we see of, that indicates multiplication. So I always think of it as of, and that tells me it is multiplication. So immediately when I see 43% of 151, I know that of means multiplication. So I'm going to, oh, that didn't work out well. So I'm going to go 40. No, I've got to use the eraser. This is not good. So 43% of, which is times 151. Now you can do 43 as a percentage on your calculator, or you can convert 43 to a decimal. So if you don't like to work with the percentage button on your calculator, you can easily make it a decimal by dividing it by 100. So you could say 0.43 times 151, or you could do 43% using the percent button on your calculator and then times it by the 151. And has anybody got an answer? 65. Perfect. So remember, we're rounding to 2 decimal places, so I'm going to leave it as 64.93, but you have rounded off correctly. So same for the next question. What is 68% of 406? So whenever I hear of, I'm thinking multiplication. So it's 68% times 406. Remember, you can always convert the 68% to a decimal. It will then be 0.68 times the 406. Okay, so let's do that quickly on the calculator. Times 406. And we get, what do we get? Zero. Absolutely. Sorry, somehow I seem to have zoomed out of my screen. So now the chat is really small and I'm feeling a bit blind. So that's why I'm like leaning into the computer. Okay, so that's perfect. 276.08. Oh, and guys, these aren't percentages now because we're trying to work out. We've been given a percentage and we're trying to work out what the value is, the percentage amount. Okay. So these here should also be relatively straightforward. Are we happy with these? Thumbs up. Awesome. So guys, I've just been thinking, let's cover everything on percentages and we'll end there. That's probably a good place to end. So there's just a couple more slides on percentages, a fair few. Okay, lovely. So let's have a look at the next one. I feel like something's missing off the slide. Okay, I'm not even going to bother with the slide because, to be honest, the wording confuses me. So let's just jump into an example and we can explain from there. So here we've got calculating the base amount. So we've looked at calculating the percentage rate. So that was where you wanted to work out, like what is 27 as a percent of 41. We've also calculated the percent amount. So where we're given a percentage and it's like, what is the 43% of 151? And then you work out a value. Now we're trying to look at what is the base value. So in this question, it says, what is the value of y if 29% of y is 116? So in other words, we're trying to find the original value before we worked out what 29% of that original value is. Anyone got any ideas on how we would answer this question? So what is the value of y if 29% of y is 116? Okay, see we've got Sarah typing. So while Sarah's typing, I will give you how I like to view this. So when I read it, I write it in maths terms as I'm reading it. So what I do generally is, so I'm reading there 29%. Now I've seen the word of, and I've told you guys of indicates multiplication. So 29% times y gives us 116. That's what Oh, no worries, Sarah. Thank you so much for participating. I so appreciate it. You are an absolute star, and I'll see you next week. Okay, so that's how I would do it. I would go 29% times y gives me 116. Then what I would do is rearrange for y. So if we've got 29% times y, how do we move the 29% to the other side of our equation to isolate y and work out what it is? And anyone remember how we would do that? So it's 29% times y. How would we move that 29% to the other side of the equation? Lovely, we would divide. So it's always the opposite operation. So if we're timesing on the one side of the equation and we want to move something across, we will divide. Okay, so that's perfect. So you can then move the 29% across by dividing by it. So y is equal to 116, and you can either convert the 29% to a decimal, like we see in the chat, and so then we can have 0.29. I tend to just keep it as 116 divided by 29%, but it's absolutely perfect if you do it as a decimal, you'll get the same answer. Okay, so what do we get if we do that on our calculators? Anybody want to fact check me? 400. Thank you so much. Absolutely. And you'll notice that if you test this out by using the decimal or the percentage, you'll come out with 400 on both. Okay, so who can help me to write out question 2 as an equation? So question 2 says, what is the value of x if 23% of x is 207? So I want someone to help me write that out in maths terms so we can rearrange the equation. Oh, now I've lost my page. There we go. Okay, I see we've got Nasira busy typing, another star of this evening. A few of you have been really, actually all of you have been great. Okay, we'll just give a moment. Okay, so we've got 23% times x is equal to 207. Exactly. Perfect. So I'm just going to make some space over here for us to do this calculation. We'll do it in a different color. Okay, so we know that 23% of, which is times, x is equal to 207. So once again, we're going to rearrange the subject of the formula to have x by itself on the left-hand side of our equation. So x is equal to 207 divided by, we can do a decimal, 0.23, or by 23%. Okay, I can see we've got some people typing, so I'm hoping someone's going to give me the answer. Oh, well, there was 207. 900, 900, 900. Thank you so much. Save me from having to do that. Wonderful. So there we've worked out that the original value was 900. And when we took 23% of 900, we got 207. So that's what we're working out here. What was that original base amount that we then took a percentage of? Okay. So we've looked at three things. We've looked at calculating a percentage rate. So for instance, the example of you want to work out your mark as a percentage. We have looked at taking the percentage of a particular number, and then now we've looked at how to calculate the base amount. Okay. Are we happy with these three different elements of percentages? Thank you. Awesome. Okay, now we are coming on to percentage rate of change. So percentage rate of change is quite important for a lot of different areas. If we think about percentage rate of change, this can be applied to things like linear equations when looking at how a straight line changes over time. It can be applied to things like if you, for instance, got a sale price and the original price, you can work out what percentage change has happened between the original price and the sale price. So it has quite a lot of applications. So to work out the percentage change, what I want you to always remember is I've simplified it here. New minus old over old times 100. What on earth am I talking about here? So after you've had a percentage increase or percentage decrease in a value, it will give you some new amount. Okay, so that's what I'm referring to when I say new. When I say old, I'm talking about what was the original value before we had the percentage increase or decrease. Okay, so if we use this formula here, we'll be able to calculate the exact percentage increase or decrease, which can be very helpful in a variety of contexts. Okay, so let's take a look here. So how would this work? So question 1 says, if the amount of liquid in a bottle increases from 1.5 liters to 1.75 liters, then what is the percentage increase in the amount of liquid in the bottle? So you can see here, we're trying to work out percentage rate of change. We're trying to work out what was the percentage increase. Okay. So help me identify here. We've got two values. We've got 1.5 liters and we've got 1.7 liters. Which is our new value and which is our old value? So it's important to be able to identify these. Okay. Nasia says new is 1.75. Absolutely. We've been told it's an increase. So the new should be the bigger value. Okay, so that is our new. And then by default, the 1.5 is our old. Okay, now that we've identified that, we can simply insert it into our formula. So our percentage increase is equal to our new value, 1.75, minus our old value, 1.5, divided by our old value, 1.5, all times by 100. Okay, and what does that give us if we do it on our calculator? So you can create a fraction on your calculator. Do 1.75 minus 1.5 over 1.5 and multiply that by 100. What do we come out with? Oh, Nasia, you're so on it. So 16.67 liters. And I love that you've included the units of measurement because that is so important. In a question like this, you'll lose half a mark for not including that. So absolutely. So we've worked out that it has increased by 16.67%. That has been our increase. Okay. So all you need to do is remember this formula. Whenever you're trying to work out a percentage increase or a percentage decrease, just remember new minus old divided by old times 100 will give you your percentage increase and decrease. Now you use the same formula when trying to work out both an increase and a decrease. The only difference is that with a decrease, you will come out with a negative answer. So you might come out with negative 16.67. Don't freak out. That negative is just indicating that it's a percentage decrease. You'll see that in an example now. So let's have a look at that example. So here, question 1 says, if the petrol in a car's fuel tank falls from 60 liters to 43 liters, then what is the percentage decrease in the petrol in the tank? Okay, so in this instance, what is the new value and what is the old value? What is the new? What is the old? So remember,
43
well,
is the new and 60 is the old.
lovely, thank you. Yes, and so we would expect that, right? Because we're dealing with a decrease, so the new value should be the smaller value. Okay, so I'm running out of space on the screen. Okay, so here I think it's more space. So our new value we've got is 43. Our old value is 60. We divide it by the old and we times by 100. And what do we get if we do that on our calculators? Okay, so remember you are going to come up with a negative answer. That is to be expected. There's me, I can see is typing yes, negative. I got negative 28.323. I think that's exactly what you meant. Okay, so we come up with negative 20, I get 28.3 recurring. So we'll make it 0.33. I knew that's what you meant. Okay, now when reporting your final answer, you can drop that negative sign because we already know it's a decrease. So having that negative sign is redundant. So in your final answer, you can simply say it's equal to 28.33% decrease. So we've worked out that in order for the fuel to have dropped from 60 liters to 43 liters, there would have been a 28.33% decrease. Okay. And this new minus old divided by old, this is going to be used in Learning Unit 7. So keep it in your mind, even after this learning unit. Okay, would anyone like us to look at any other examples with percentage increase or decrease? Or are you happy for us to move on to the next percentage concept? I got one thumbs up. Everybody else? We're still going strong. I'm absolutely amazed by you guys. You must have like unlimited supply of coffee or something. All right. So here we are looking at adding or subtracting a percentage. So there's this formula that we use when we want to add or subtract a percentage. And I think it's best that we just jump straight into an example rather than focus on the formula here. All right, so let's have a look here. So this is when we're adding a percentage amount to a base value. So it gives us this formula to add X% of Y to Y. We would use the following: 100 plus X% times Y. Okay, that makes no sense to me until I actually apply it. So let's have a look at how we would do that. If an employee receives a 13% increase on his old monthly salary of 18,500 Rand, what is his new monthly salary? So there's two ways to work this out. And the first way might come more intuitively to you. So you might think, well, why don't I just work out what 13% of 18,500 Rand is and then add it to the original salary? You absolutely can do that. Alternatively, you can use the formula on screen to do it in one step. So in this case, if you think about it, 100% would be equal to the original salary of 18,500. Now, if we take the 100% and we add 13, so in other words, we take 100 and we add 13, and we make that a percentage, this is essentially saying we want 100% of the salary, the 18,500, and an extra 13% to take into consideration the increase. And then we're going to times that by the 18,500. So in other words, we want 113% of the 18,500. And that's going to give us the increase. So do you see how I'm using that formula? We're saying, okay, we want to add on to 100%, which would have been his full original salary. We want to add on 13. So that's why we end up with 113% times the 18,500. And I'll show you the other method as well. It's also completely fine to work out what is 13% of 18,500 and then add it. Completely fine. You won't lose marks if you use an alternative method. I'll do this on my calculator while we 18,500. Thank you. There we go. Nazira's got the answer there. Lovely. It is, your salary would increase to 20,905 rands. Okay. I can see Thasme is typing. Would you like me to show you the alternative method as well, or are you happy with this? Absolutely no problem. We are nearly finished. We're literally going to look at one more question. I know it's been a long session. Absolute pleasure. And thank you so much for joining and for participating. All right, guys. So let's just take a look at one question where we are now subtracting a percent. So you'll see in the previous formula where we wanted to add a percentage, we took 100% plus the percentage we wanted to add. Now we want to subtract a percentage, so we will take 100 and we will subtract whatever percentage we want to deduct. So here it says, if an employee earns a gross salary of 23,750 Rand and she pays 21% tax on this amount, then what is her monthly salary minus tax? So here we would take 100% would be the 23,750. So we want to minus from that 100% the 21% tax. And then we want to times that by her original salary. So 100 minus 21 gives us 79. So we'd end up with 79% times 23,750. And what would this give us? Absolutely, 18,762. For me, that is far too much money to the tax man. Thank you very much. 18,762 and 50 cents. Okay, so is this making sense regarding taking a full 100% and either adding to that 100% or deducting from that 100% depending on what we're trying to achieve? Okay, thank you for the thumbs up. Right, so lovely people, I want to ask, before we end off for tonight, looking at some of the sections that make up Learning Unit 1, is there anything in particular here that we haven't looked at tonight that you would like me to look at while you have me here? Or are you happy for this evening? I'm happy to look at any one of these sections with you. Ratios. Okay. I thought that was going to come up. And it's a good one. It's a very good one. Okay. All right, folks. So I'm hoping you are happy to stay for ratios. This is actually a very important one. And I'm going to give you a little hint here. In my 5 years of teaching this module, I have always seen the same ratios question appear. So when I teach the ratios section, sure, we look at what is a ratio, but then we look at how is it going to be asked as a question. And so I find it helpful to put an example on screen, and then from that example, we will look at the various methods. So are you happy with that? So I'm going to put a scenario up, and then we will teach and learn the methods from there. Okay, great. So the context in which we generally look at ratios is in the context of a business. So before we even start, can anyone give me a simple example of what a ratio is? It can be a very practical example, so like something you use in your daily life. Anyone got an example of what a ratio is? While I get the question for us to look at.
The amount of sugar that you put in your tea.
Yes, I love that. That's a really good one. I always think of when I was young and I used to drink like Oros, and I'd say, okay, I need this much Oros for this much water. That was my first understanding of what a ratio was. So if I increase the amount of water that I have in my glass, I need to increase the amount of Oros I have in my glass. There was a certain ratio that I liked. So I think there's plenty of practical examples of ratios that you can see in everyday life. In the context of this module, when we're looking at ratios, we are focused on profit share. So what we do is we look at a group of people that have started a business and they have contributed capital to start this business in varying amounts. And we use those varying amounts to dictate how much profit each of the different partners will receive after their first or second year of operating as a business. So let's read this question and then I'll take you very slowly through the steps of how we use our knowledge of ratios to solve it. So it says, George, Jan, and Zizi start a new company. They agree to share any profits or loss made by the company in the same ratio as their initial contributions to startup capital of the company. George, Jan, and Zizi's respective contributions to startup capital are 250,000, 150,000, 100,000, and total profit in the company's first year of operation is 120,000 Rand. Okay, so what they've given us here, they've told us they're 3 business partners. Each has contributed a different amount to starting the business. They've also told us that in this company's first year of operation, they made 120,000 Rand. So the first part says, write the contributions to startup capital as a ratio. Now, what I've done with this question, and it won't be like this in your exam, is I've broken this question into steps. And these steps are your method that you're going to follow. When you get this question in a test or an assignment or an exam, it's not going to break it down for you like this. So you need to know that these are the steps that I have to follow in order to get to my solution. Okay, so how can we write their contributions to startup capital as a ratio? Anybody have any ideas? So I'll give you a little hint. So if I'm talking about my OROS, I might say I use 2 caps of OROS for every 1 glass of water. That's how I would write a ratio. 2 is to 1. So using that, how might we display this information in the form of a ratio? And I'll also help you by saying that the ratio should look like this. So it should be George to Jan to Zizi. Any guesses here? I know it's unfamiliar, so Lali. Well, I got it down to 5, is to 3, is to 2, but this is the easy part. Absolutely you. I'm amazed. And you've simplified it and everything. Okay, that's great. Absolutely. So just to show you how we would start off, and I'm so glad you guys have simplified the ratio because there's actually a mark allocated to simplifying the ratio. So to start off, we would say that George has contributed 250,000. Then we would use the semicolon to now indicate that it's a ratio. Jan has contributed 150,000 and Zizi's contributed 100,000. Okay, this is a simple ratio right there. I'm trying to get it to be all on one line. This is irritating. I don't like it like that. No, guys, this is not right. You know, when you've got a text box and you just want everything to be, I'm going to write it out. Okay, so we had 250,000 to 150,000. And would Mithlali or Mashia, would you like to tell us how you went about simplifying this ratio? How did you get it down to 5 is to 3 is to 2? What did you do to simplify it?
I divided it by 50,000 as a common ground for all 3 contributions.
Wonderful. So it's about finding the highest common factor between all of our different elements of the ratio. 50,000 is fabulous. If you are someone who struggles to see the highest common factor, you can also slowly simplify it. So you could say divide it by 1,000, then you see, oh, actually it's still quite big. Then you divide it by another number and you slowly get it down to its simplest form. But if you can straight away see, oh, 50,000, if I divide each by 50,000, it simplifies it for me, then great. So in this instance, we're dividing by 50,000. Now, because we are dividing each element of the ratio by the same number, it's still an equivalent ratio. We're not changing the ratio. It is equivalent. It's just a simplified version. Canceling. I also do canceling. So sometimes what I will do is I'll say, okay, I can see that all of these numbers have got 4 zeros. So I'll be like, okay, we can cancel out 4 zeros. That gives me a slightly more simplified ratio. Then it's quite easy for me to see, 5 goes into 25, it goes into 15, and it goes into 10. 5 goes into 25 5 times, it goes into 15 3 times, and it goes into 10 twice. So if you can't immediately see the highest common factor, that's okay. You can do exactly like what I've done here. Cancel some of those zeros, and then see from there if a highest common factor jumps out at you. Okay, cool. So we've done the easy part. We've created the ratio. Now it says write each person's share of the total profit as a fraction. Okay. Any ideas on this one? So we've got a
Didn't we
ratio.
add
Yes,
all the ratios together and then divide by the
you
total profits?
absolutely right. Yes, that's fabulous. So what we will do is to come up with the denominator of our fraction, we need to add each element of the ratio. So if we take, and I should just label this is question 1, and let's do a different color for 2. Okay, so if we take 5 and 3 and 2, we obviously get 10. That basically tells us that the total profit that they could get is 10 effectively. Okay, that becomes the denominator of our fraction. So for all 3 of these people, for George, Jan, and for Zizi, we know that writing this as a fraction, the denominator for all 3 will be 10. So I'm just going to write here George, and then Jan, and Zizi. Now, looking at our ratio, we can see that George gets 5 out of the 10 parts of profit. Jan gets 3 out of the 10 parts of profit. And Zizi gets 2 out of the 10 parts of profit. So do you see how that is how we're using the fraction to indicate what share of that total profit each person's getting? Was that a question? I saw a hand go up. Devani.
Hi, ma'am.
Hi.
Yes, hi. Right. I just quickly logged in just to see what was going on, but I have
Yes.
to dash out now. I have another
All
lesson right
good.
now.
All
So I'm
good.
yeah. Cheers. Thank you, ma'am.
Thank you so much. I'll see you next week.
No problem.
Cool. All right, guys, so we've created our ratio. Now we've created our fractions. Now what I want you to remember, like I said earlier, the question's not going to be phrased like this. The question is going to ask you straight up, it's going to jump to part C, and it's going to say, calculate how much each of the partners received that year as profit. And now from that, you need to know, step 1, create the ratio. Step 2, convert the ratio to a fraction. Then step 3, calculate each partner's share. And that's why I've written 1, 2, and now I'm about to write 3, so that you remember these 3 steps, and each is worth marks. So having a simplified ratio, that is worth marks. Having these fractions, that's worth marks. It's not just your final answer. So now what I like to do is use the word of. As I mentioned, of indicates multiplication. So I kind of read it out to myself. I'll say, okay, so George gets 5 of the 10 parts. What was the profit? Let me just scroll up. It was 120,000. So he gets 5 over 10 of 120,000. So let's write that here. He gets 5 out of 10 of the 120,000. Jan gets 3 out of the 10 parts of the 120,000. And Zizi gets 2 out of the 10 parts of 120,000. Now, of indicates multiplication. So this means that we simply need to multiply the fraction by the 120,000 to work out each person's share of the profits. So we can do this, and you guys can help me. I'll work out for George, and if someone can help with Jan and Zizi. Oh my gosh, amazing. Lucia, thank you. So we work out that George gets 60,000 Rand of the profit, Jan gets 18,000 Rand of the profit, and Zizi gets, I feel like Jan should be getting more than Zizi. So times 120, 1, 2, 3. Oh, okay, it is 36. But I think, so we can see that because Jan gets 3 out of the 10 parts and Zizi only gets 2 out of the 10 parts, that technically Jan should be walking away with more. That's a quick indication. And it is indeed 36,000. And then for the last one, I think the last one is 18,000 if I'm not mistaken, but I'll double check. Oh, it's 24,000. Thank you, Nashira, Charlie. 24,000. Okay, so we've now worked out, based on their ratio of contributions to startup capital, how much profit each person will receive at the end of that first year. So just to recap of the 3 steps, the first is to create your ratio, then convert your ratio to a fraction, and then multiply that fraction by that year's profit, and it's going to give you that person's share of the profits. How did that seem? How is that to you guys? Got it. Wonderful. I'm so glad. Everyone else? I'm hoping. Mislali. Okay. Awesome. No, that's perfect. We're going to finish here then for this evening. I just want to say thank you so much to everybody for joining, and I really hope that it was helpful. The recording will be shared. So thank you so much for your participation, for helping me answer the questions. You've really all been fantastic. I know it has been a long session, so I really appreciate that, and I will see you guys soon. Have a wonderful evening.